All right, let's talk about a piece of technology that truly changed the game for anyone who builds or runs software. It's called Docker, and it was created to solve one of the most maddening problems in the entire tech world.
Oh, this phrase. If you've ever touched a piece of code, you've probably said it, heard it, or been driven crazy by it. It's that classic moment when an app runs perfectly for the person who built it, but is completely broken for everyone and everywhere else.
And, this isn't just some small, funny annoyance. It's a huge, fundamental problem in software. So let's dig into why this happens all the time.
See, the problem is that no two computers are ever really the same. Your machine has a slightly different operating system version, a different library installed, a different configuration file, and any one of these tiny little differences can cause total chaos and make an application just fall over.
And what you end up with is just a huge mess. It makes building things slower, it makes putting software on servers a nightmare, and it just creates a buggy, unreliable experience for the people actually trying to use the app. There has to be a better way, right?
Well, there is. And this is where Docker steps in with a solution that is just so clever. It basically lets you create tiny, perfect, self-contained computers for your software to live in.
Officially, this is called a Docker container. And really, it's just a complete package. It bundles up your application's code and all the little bits and pieces it needs to run, the libraries, the tools, the settings, all into one neat little box that works the same everywhere. Honestly, the best way to picture a container is as a tiny little computer that has one and only one job. Maybe its job is to run a website or a database, and it does that one job perfectly, totally sealed off from everything else around it. And this idea of isolation is the magic trick. Each of these microcomputers gets its own slice of memory and processing power. So you can start one, stop another, or run a dozen of them right next to each other, and they won't interfere. Your software stops caring what computer it's on, because the container is its own perfect little computer. The "it works on my machine" problem, it's gone.
Now, if you're thinking, hang on, this sounds a whole lot like a virtual machine, that's a really good thought. But the difference between them is absolutely massive, and it's the key to why Docker is so powerful.
The difference is just night and day. A virtual machine, or a VM, has to run an entire guest operating system for every single application. It's huge, it's slow, and it eats up tons of resources. But Docker containers? They're so much smarter. They all share the main operating system of the computer they're on. This makes them incredibly lightweight and fast. They start in seconds, not minutes, and they're tiny. We're talking megabytes instead of gigabytes.
And here's the bottom line. This efficiency completely changes the game. On the very same server where you could maybe only run 2 or 3 heavy virtual machines, you could run dozens, maybe even hundreds of Docker containers. It's a revolution in efficiency.
Okay, so we get what Docker is, and we get why it's so darn efficient. But how do you actually go from having an app to having it run inside one of these containers?
Believe it or not, the whole process kicks off with a simple text file. This file acts as a blueprint, a set of instructions for building your perfect little microcomputer. It's called a Docker file.
And the workflow is this beautiful, simple 3-step dance. First, you write that Docker file with all your instructions. Second, you build an image from that blueprint. Think of it like a frozen, saved snapshot of your setup. And finally, you run that image, which brings it to life as a running container. Write, build, run. That's it.
And please, don't let the word code or blueprint scare you. A Docker file can be ridiculously simple. For example, this single line, "from Ubuntu," is a totally valid instruction. All it does is tell Docker, hey, start with a fresh, clean version of the Ubuntu operating system. From there, you just add lines to install your software. It's that easy.
But here's the best part. You almost never have to start from scratch. Why? Because the worldwide Docker community has already done almost all of the work for you.
Let me introduce you to Docker Hub. The easiest way to think about it is like an app store, but for server software. It's a massive online library packed with millions of pre-built, pre-configured application images that you can download and use right away.
And getting started is dead simple. You just search for what you want, say a Plex media server or a Nextcloud file server. Then you type docker pull to download the image and docker run to start it up. Yep, with literally 2 commands, you can have incredibly powerful software up and running. It's amazing.
So what this all means is that the wall between your idea and a real, working, portable application has just been completely torn down. That whole "it works on my machine" problem is finally solved. Your software can now run reliably, absolutely anywhere. So the only real question left is, what are you going to build first?